Okay, we're just going to wait just a few minutes while we wait until 2 p.m. when the official class time starts. Let me go and share this for the moment. It's kind of like an attendance form. Oh, hello. Yeah, it's the winter break went by very quickly. And at the same time, we're starting pretty late this semester. Usually we start, I think, a week and a half or 2 weeks earlier. So it's kind of interesting to be starting in February. I was looking at the calendar because of that, and I think they pushed us further into May, if I'm not mistaken. So exams are like in the middle of May now. Is that correct? Yeah. Yeah, I was counting up the weeks. I think we have about 15 weeks of classes. So I'm going to try to make the most out of that time as possible. It was pretty good. It was filled with a lot of research. It went by really quickly. I hope everyone had a pleasant winter break. I'm really looking forward to being able to start teaching classes in person again. This is going on a full year now, teaching classes remotely. I do find it disruptive. It's hard sometimes to find a good flow. So yeah, I do feel like I'm more productive in my office, working around other people who are also working. I think that's the thing I miss the most, is having to work just in isolation. Somehow, like, it's better to get into a better mindset to be working when you see everyone else around you also working. I also miss a lot of the student community stuff, all the student organizations and whatnot. It's been very hard to try to do anything community related through like Discord or Zoom or things like that. Okay, let's see. Oh, it's 2:01 right now. So I have 32 participants. I think that's probably pretty good. So let me first start by just letting everyone know that these lectures that we'll hold on Tuesdays and Thursdays, I'm going to go ahead and record them. It should show that I'm recording them, I think, somewhere on Zoom, so that they could be made available through Moodle. So I'd like to welcome everyone to 4208. This is Developing Advanced Web Applications. And so I'll try to make the most out of my hour and 15 minutes that I have today for the first lecture, February 2nd. Okay, let me start by sharing my screen. Okay, I'm going to do my entire screen, select that, and share. So at this point, everyone should see my screen. Is that accurate? And I'll just check in the chat window just to make sure. Yes, perfect. Okay. So first thing I'm going to do is just to keep track, because I have a difficult time visually being able to see the 32 other participants in here. I'm going to publish a form in the chat that you can go and log into, just so that I can easily track who's coming to the lectures. Just makes bookkeeping on my end a little bit easier. Okay, So for today's lecture, I want to introduce what we're going to be learning for the rest of the semester. So I'm going to jump over to my lecture slides and I will narrate over them. Okay, so this is 4208, Developing Advanced Web Applications. Today, I want to go over the syllabus. I want to talk a little bit about the philosophy behind this course. I'm going to give a very basic overview of what it means to be a full stack web application and what the various pieces are to kind of give you a roadmap as to what to expect you'll be learning over the course of the semester. And then I want to hit my first part of Unit 1 is try to describe a little bit about a web client. In particular, the web client we'll be talking about is a browser. And then we'll talk a little bit about HTML. So this is what I would like to discuss today. And if at any point you have a question, let me see if I can't do this. Let me take this and let me get this tab here. There we go. Okay, so if you have a question, let me know in chat, and I should be able to see my chats right here in the corner. Okay, perfect. So I'm going to start with the syllabus. Slide 1, use the syllabus. Perfect. So let's jump over here. So everyone should have received the syllabus in email. I also have this posted in Moodle. So the first thing I should do is introduce myself. I'm Ted Holmberg. My primary role at the university in the department, in fact, is to serve as the industry liaison. And so what I do in that capacity is I communicate with a lot of our industry partners to find out what skill sets they're looking for, either at the internship level or at the junior developer level, and to ensure that we find a place somewhere in our curriculum so that you can learn those technologies, skill sets and whatnot. And so one of the motivating reasons behind having this course is there's a lot of job opportunities for those who know how to do web applications, full stack web applications. And in particular, I've crafted this course to teach the technologies that are most sought after in that capacity. So again, one of the motivations for me in designing this course is to try to teach you the skills that will look great on your resume, that will look great as you're interviewing for a job, and really prime you to be able to get a job after you graduate, or even if you're looking for an internship. So even getting an internship while you're still taking courses. So there's multitudes of ways you can contact me. Not the office though. This is I keep that on there in case we ever have a live person class again. But you can call me, although I do not prefer this. You could email me, although I do not prefer this. We will meet in Zoom. So this is my, I guess, virtual office as of now. So I'm just going. Oops, did I open up mail by accident? Let's kill that. Quite. By highlighting my mail and opened up the mail app. Okay, so this is going to be my virtual office. So we'll have lectures here Tuesdays and Thursdays, and I'll talk a little bit about the philosophy behind these lectures when I get into that part of the syllabus. And so the primary way that I'm going to do office hours, the primary way that I want to try to foster course discussion is going to be through Discord. And so I'm essentially going to kind of mandatorily try to set it up so that everyone joins this Discord channel. So I gave a link to that in the initial email. If you haven't joined the Discord channel, please do so at your earliest convenience, because this is where you'll be able to ask me questions on debugging projects, or for additional clarifications on concepts, or just be able to cross-communicate with the rest of the class. This would be where our course community is. Now, one of the powerful things about the Discord channel I'm going to use is it has the advantage that this is the same Discord channel I used last spring 2020. So you'll notice when you join this channel, the instructor, which will be me, will be highlighted in gold, and then you'll have a set of users who are highlighted in green. So you guys will have the advantage of the previous class alumni to also be able to ask questions or see their projects or just be able to have a dialogue with related to web applications. And then on top of that, all the course content will be disseminated through Moodle. And just to keep things as transparent as possible, I imported the Moodle that I used for this course last year, and I just made everything visible. However, I can't state this enough. Only you can preview things, but don't necessarily look at the labs that I haven't assigned yet or the homeworks I haven't assigned yet and think that those are going to be the same homeworks. So I am refactoring this course as we move along, but I just want to give you all of the course material from the get-go so that you can work at your own pace. But understand that the turn-in projects are going to be assigned as they're constantly being refactored. With that said, I have refactored the first lab and the first homework, and both of those have been made available on Moodle. Probably the best way to check on Moodle is usually Moodle has like a calendar that you can check of due dates, and just check the things that are due most recently. Unfortunately, there's still some things that it claims to be due, and that's because of the default settings when I imported it. But I will say that I do have Lab 1 and Homework 1 that has been published already. So let me talk about the format of this course, since it's going to be an online delivery. I envision 3 different components of this course. So you can have pre-recorded video, and I'm going to try to make more of my own pre-recorded video. I've been playing around with some editing software, but I also scoured the internet for some good videos that I thought were pretty educational, and I've posted those on Moodle. So a lot of the theory-based concepts, I would like to make those available in a mechanism so that you can watch it and rewatch it and rewatch it until you get a firm understanding, or so that you can go back and reference it again if need be. And so what that would allow me to do is really free up my lectures to be more application-based, where we can try to debug code, we can look at edge cases, and I could show you how we could take some of these theories and apply them in practice. Now, today we'll talk about a little bit of the theory, and every so often in these lectures we'll talk about theory, but for those of you who have had me before, maybe in 1583 or whatnot, you might know that I very much prefer a more workshop-oriented style class where I go straight into the source code and explain the underlying concepts of what's happening there. And I would like to keep to that spirit as much as possible in this course. But I do understand, like, a lot of times you can't just do source code by itself. So those times where we need to talk theory, we will pivot to PowerPoint slides or whatnot. And then the third component of this class is going to be these student hours and discussions, which is in Discord. I love Discord because it provides this persistent communication and allows for text, voice, and video chat. So if for any reason you need to ask me a question, do not send me an email. Hop onto Discord. I have it set up on my phone, so it should alert me just like a text message, and you can go ahead and query me, and I'll respond back at my earliest convenience. Sometimes it might be immediately, sometimes it might be a little later in the evening or whatnot, depending on what my schedule is. Okay, with that said, is there any questions in terms of just the delivery methods of the course and ways to get in touch with me? And obviously you know where the lectures are because you're here listening to me. So with that said, the prereqs for this course are either data structures or systems programming concepts. I don't think you could be in this course without those prereqs, so they're just there to ensure that you've been able to develop source code projects on your own. So a quick description of this course. So this course is really going to focus on the design and implementation of what we're going to call advanced web-based applications. We're going to cover a vast number of technologies. I'm not going to bother citing them off because I'm going to assume you can just read through the syllabus. But this diagram kind of illustrates the various components we'll learn throughout the course of the semester. So when we build a full stack application, it's typically defined as having 3 different layers. So you have your client end layer, your front end layer, which typically resides in the browser. So you could think of this part as the work or implementation we'll do in the browser. And then you have some web server, which is responsible for listening to web clients and sending them HTML documents, sending them CSS documents, sending them JS documents, sending them JSON data. So essentially, the web server serves web clients and gives them back data. So in the initial part of the course, we'll look at building web clients, and then we'll look at, in the second part of the course, we'll look at building web servers to service web clients. And then at the latter end of the course, we will then look at creating a data layer, database that will service the web server. And again, we'll talk more about this as we get into the semester. I just want to give you a firm idea of where we're going with this. And the technologies we'll be using in particular, we'll be using HTML, CSS, and JavaScript on the browser side. And if we can find time in the 15 weeks that we have in the semester, I would like to go through React as well as our front-end framework. For our web server, we'll be using Node as our runtime environment to run JavaScript. So we'll be running a full JavaScript stack. And we'll use Express to be able to set up our web server and our application layer. And we'll use Mongo as our database layer. So we're going to learn what's typically referred to as the MERN stack. Again, 100% JavaScript stack. It's a very popularly used in industry. And it'll allow us to do everything we need to do in one language. If you haven't learned how to program JavaScript, that's okay. One of the philosophies I'm going to use for this course is that we're going to have an expectation of some zero knowledge of web development. So I'm going to assume whether you've had it or not, that you don't know what a web application even is, what HTML is, what CSS is, what JavaScript is, what it means to develop code on either the client end or the server end. We will cover all of those concepts, and we will have work that delves into all of those concepts. Okay, so the resources you're going to have for this class is, well, for textbooks, I have not found a textbook that I'm happy with, and one reason why is that this field just changes so rapidly. Any textbook that is made last year would be deprecated by this year. And so for that reason, any information, all reading material that I want you to be familiar with, I will have posted on the Moodle. And in fact, I've already done the work of kind of curating over a big collection of materials that relate to this topic. So it should already be available in Moodle. And I will assign the reading materials when things are relevant, but by all means, you can look at the Moodle ahead of time and delve into it. With that said, the actual equivalent to the textbooks we're going to be using, depending on whether we're developing our front-end applications or back-end applications, are going to be the actual APIs and the online documentations for the tool sets that we're going to use. So that's the best place, in my opinion, to ever learn about a new technology. It's not necessarily through a textbook, but it's directly from the essentially the vendor or the studio who maintains the code base. So in this instance, for anything related to front end, and so for front end, you can think HTML, CSS, JavaScript, Mozilla. Oops, did not mean to open that. I think I closed my tab. That's okay. Let's go to history there and hit back. Okay, so Mozilla, who maintains the Firefox browser, goes ahead and has a awesome developer network where they give you all the specifications for HTML, CSS, and JavaScript. So this is a great resource for being able to see everything you can do inside the browser. In addition to that, they have some great tutorials on W3 Schools. So if you want to if you want to kind of get a head start on learning this material, and if you haven't touched things like HTML or CSS, it would behoove you, it would definitely be a benefit to just check these resources out. Later on in the semester, after we're done doing some front-end applications, we are going to move on to the back end. And in those instances, like I said, we're going to use the MERN stack. So that's, it's going to be, let me spell it out with the MERN. So it's going to be Mongo, it's going to be Express, it's going to be React, it's going to be Node. So I gave each of those web pages that include all the documentations and API and their own actual sets of tutorials. So again, these are great resources if you're looking to learn more than what we will cover in the lectures. And by all means, you should. Like, you should definitely check out those pages and give them at least a quick gander. Okay, so I want to kind of talk about my learning objectives here. I spent a lot of time trying to devise the best way to cover the content for this course. Typically, when this type of course was taught previously, using Ruby or using maybe Spring. Ruby on Rails is one popular framework, and Spring is a backend web server, web application layer for Java. They typically start at the back end and then kind of hastily throw in concepts from the front end. So I'm going to invert the way this class is typically taught. I think it's more natural and it'll be easier to get a grasp of just doing front-end applications. And so the technologies that we're going to learn to do this front-end web applications that are going to strictly run inside of our browser, it's going to be HTML, it's going to be styling with CSS, it'll be producing the logic for our front-end web application with JavaScript. We'll make use of the browser API, like learning about the document object model and web stores and sessions and cookies and all of that great stuff. And then we'll start learning about what it means to create a piece of software that can use a REST API. So we'll learn a little bit about asynchronous programming and how to make calls to a web server from our application, wait for the web server to respond with that data, and then use that data to move forward with whatever processing we need to do. In addition to that, I would like to teach React, but understand, I'll make that decision throughout the semester. This is all going to be kind of tentative to change based off of how far we can move along with the 15 weeks that we have. On the Unit 2, for the backend web apps that we're going to make, we'll learn how to use Node and NPM. So NPM is a package manager that can install modules and libraries in Node. And Node is just it's an OS level JavaScript runtime environment. So every browser can run JavaScript. It has its own runtime environment. Kind of, you could think of it as its own kind of, in sense, what the JVM does for Java. The browser has its own environment that executes JavaScript code. So Node is just an OS level of that, where we can run JS code without having to have a browser. Let's see, which framework do you think is more powerful, React or Angular? I will say, I think React gives you a lot more flexibility. And for that reason, it's more powerful. React, if you look at the popularity between the two, has definitely gained a lot more traction in industry and is supported by far more sets of studios than Angular. Angular was first to market, but React has really done a lot to dethrone Angular's initial popularity. So if that answers your question at all. And we'll talk more about what the difference between Angular and React is. Oh, so that's a very good question. So technically, so a lot of times Angular is definitely a framework. React is in this nebulous zone of whether it should be considered a framework or a library. One of the big things about React is it's more technically a library than it is a framework. And so I guess to articulate that, Angular is a one-stop solution by which you can develop as a platform the front end components of your web applications. Whereas React is one tool, one library that you can import, and oftentimes requires additional tools on top of that. So yes, you're right. At the very technical level, React is typically considered to be more a library than as a framework, but it gets compared a lot to other frameworks out there. Let's see. Oops, not quite what I wanted. Although I need to be able to scroll down. Okay, perfect. And for those of you who might be unfamiliar with this discussion between React and Angular, again, this is just first day of lecture. We'll talk more about these technologies as they become more relevant. But I'm glad to see that, you know, we're already having discussions about like technology choices on day one. That's a lot of fun. I'm not really familiar with remote website. What is that?
We use this like remote website for systems, and it has like all like Sublime programs to where that you can use it as much as you want. Like it already has everything installed on it.
I got you. So it's like an online dev environment where essentially you can log into like this remote platform, and
you log into the UNO computers.
Oh, excellent. Oh yeah, by all means you can do that. That's outstanding to know. I didn't even know that that was a service that was being offered. So thank you for sharing that with me.
No problem. Thank you.
But yeah, I'm not going to be very restrictive on whatever you decide your development workflow to be, and I'll try to support you in whatever choice you decide to on how to develop your code. I care at the end of the day more about the application that you develop and how it executes. In fact, when we get more into the grading, I'll talk about how I'll grade all of the applications and whatnot. Because I definitely do a non-conventional approach to grading that I want to articulate. Okay, so the first unit of the course is just going to essentially delve with all the technologies that exist within the browser itself. The second, unit 2 of the course, is going to delve with all of the technologies that are required to actually create and implement a web server that handles client requests. And then the third unit, if you want to call it a third unit, is going to talk about our database integration so that we can actually maintain all the data for your app on a layer that is separate from the server and separate from the client. And there's a really good reason why we want to have our data separate from the server. But I don't want to spend too much time on day one with that. I'll just let you know that essentially our course is going to be set up in these 3 separate units. So this is probably the part most people are interested inside of the syllabus. I know this is part I was really interested when I got my syllabus. How are the grades kind of determined? So on conceptual stuff, I'll do online quizzes, and online quizzes will account for like a total of 10% of your grade. So online quizzes, when I make them available, will be, you'll have unlimited time. It'll be a Moodle quiz with unlimited time and unlimited attempts. So you can take your time and read up and scour the internet for references, or if I'm asking you implementation-based questions, you can log into a JavaScript runtime environment and try to like hack together to see what the result of a implementation question might be. The entire point of the proficiency quizzes, though, is to be able to make sure that you understand the underlying concepts. So I don't care about like having to memorize things in anticipation of an unknown variety. I care more about you being able to state answers to concepts or state results to implementations. A much larger portion of your grade, though, is going to be the practical labs, the coding homeworks, and then the final project. The practical labs are really simple, although they could be a little bit long. they're going to be step-by-step instructions where you're going to implement some specific web-based technology. And so the goal of these, the labs is to essentially provide you with a walkthrough on how to implement a project in HTML, how to implement a project in CSS, how to implement a project in JavaScript, how to implement a project that uses a REST client, how to implement your own web server. So in Node or Express or something like that. So the labs won't have you doing any critical thinking. It'll just step you through the process to see and experience how to use that technology, starting with no source code and going down to having something that's complete. And that way you can use that as a reference point for your own projects. So this is very much a style of teaching that I like to call an apprentice approach, an apprenticeship approach, where the labs are designed to very explicitly show you how to do something. And then often will be the case, I will then ask you to produce some project of your own design using the lab as an example, just to illustrate that you can show to me that you understand how to use that technology to build into a web application. And so all these technologies, one of the big things about web applications is all these technologies that exist at the client end and that exist at the server end, they all are designed to modularly fit together to build a full stack web application. So the entire point of this course is to learn how to build our own full stack web application. So the greatest majority of your course credit, 35%, will come from a final capstone project, where you'll take what you've learned and actually start to design a project of your own making that has its own front end, that has its own back end, and that has its own data schema and database. So for the practical labs, for the coding homeworks, for the quizzes, those are all designed to be individual. For the final projects, I'll leave it the decision to you on whether you want to find a team person through the Discord channels or whatnot to work with, or whether you want to work it all individually on your own. So that the final project, I do recommend doing as a team, but if you prefer to do it on your own, I won't dissuade you from that. Now, let me talk about how grading works on anything that's not a quiz. Quizzes are super simple because it's automated, and as soon as you hit submit, it's going to give you a grade, and then you know what you made. And if you're not happy with that grade, you could just take it again, right? Unlimited chances on quizzes. The labs are pretty simple for grading purposes. You submit that. I'll evaluate the lab. I'll make sure that all the steps, that you've implemented all the steps and that it actually executes as per expected. And then I'll give you a grade based off of being able to implement based off of my steps. The more interesting thing is, how am I going to grade the final project and how am I going to grade the coding assignments? But both of which combined make up, what is that, 65% of your grade? I will have you go ahead and submit your project through Moodle, but you'll only get a grade based off of doing a project audit. So if you go into Discord here, and so this is Discord. I would encourage everyone to join Discord. Like I said, I'm in the yellow. We have alumni in the green, and then we have all the other current students who are enrolled this semester. And after you get through this class, you'll be promoted from just the default white color to a green color. So you'll see I have a couple of channels. You have the general channel, and you can probably see the history of everything. This is a great place just to have a communication with the rest of your class, and this is where you can post source code, and I'll go ahead and help debug. And we can actually crowdsource this a bit with alumni students as well. When it comes to getting your homework graded, you'll see you'll have this request audit. In request audit, you can go ahead and tell me a day and time that you want to be able to show off one of your homeworks or your projects. And here I'll reserve that time for you, and then we can just meet either in Discord or we can meet in Zoom, and we'll have like a 15-minute video chat where essentially you show off your source code, or actually you show off your application of what you designed to do, demo it out for me, and then we'll delve into the source code and kind of look over the source code. And that way I can give you my feedback immediately. Because at the end of the day, that's what you want from these applications. You don't want to just be designing applications. One of the purposes is that you get my feedback on how you could make that application better. And so after doing this process for about a year, I found that just submitting these homeworks the way we traditionally did in class, where you give it to me like I'm in a black box, and then I write on it and I give it back to you. And it's this very like non-social way of giving you feedback. And using these digital platforms, I've definitely learned that being able to do live interactive assessments of your projects has been a far better way for me to see your project and for you to get my feedback on that. So I'm letting everyone know ahead of time, like all projects will be graded in person, where you get a chance to kind of talk about what you did and show off at what you did. And it not only gives you better feedback, but it also fills, I think, a niche that that a lot of industry partners kind of request that we do more of it with our classes, which is have students talk about coding and talk as if they were part of a team or addressing a project manager. So I'm trying to capture the same experience you would have as a professional developer having to talk to your project manager. That's one of the motivating goals behind that. Okay, isn't that a code editor? Are you talking about terminal.cs.uno.edu? It might be. I don't know. So we don't have any exams. That's right. So for those of you who wonder, this is, I like to try to, if possible, keep my courses as practical as possible. At the end of the day, when you go through a course, you have to be able to apply the concepts to develop software. If they're just left in a conceptual realm and you know how to think about it, but you don't know how to use it, then you're not coming away with something that's very industry worthy. You don't have something that you can really apply in a meaningful way. And so I care more about making sure everyone comes out of here with a great portfolio. In fact, over the course of the semester, we're going to be building a portfolio page. Everyone's going to build their own portfolio page. They'll probably manage their own blog for each release of each of the homeworks. And the thing that you'll get all of your grade on for the most part is being able to produce code, being able to produce projects, and then finally being able to produce a big capstone project. So you do not have to worry about tests in this course. Any concept-based stuff will just be pushed into the quizzes. But at the end of the day, learning the concepts is really there to facilitate your ability to do. And that's, I think, the best way to evaluate you, if that makes sense. Excellent. Okay. So let's see here. Oh, and that's the rest of my syllabus. So let me go back to my lectures. Let me go back to my slides. Okay, so let's talk about course philosophy now. So what is CSCI4208, Developing Advanced Web Applications? I wish we had auto. Okay. Will the presentations be in front of the whole class or just in front of the professor? Oh, that's a good question. So the presentations will only be, it'll be just a one-to-one presentation, just me and the student or students who have a project to demo out. And oh, but let me also say this. I treat this very much as a project management endeavor. So I told you I grade very unconventionally compared to other professors. Where most professors will try to power through the grading portion by giving a some measured grade on what the initial turn-in was. And what I mean by that is they'll look and say, oh, this is comparable to a C, or this is comparable to a B, or this is comparable to an A. I do not use that approach. I will do the same thing that they would do in industry. In industry, if you turn in something subpar, they don't say, okay, you finished that task. It's about a C rating, not quite what I would have expected, but now it's time to move on. No, what would normally happen is if you get, you would get feedback on how to improve, and then your next task is to improve on that. And so that's the same kind of expectation you can have with these project audits. Project audits don't necessarily have to be part of the final submission. If you get stuck, I will help decode or debug or peer code with you. But if the project that you submit for audit is not up to what the expectations are, I'll tell you how to improve it, but I won't give you a grade yet. I will defer giving you a grade until you've hit the expectations for that assignment. Does that make sense? This way, I give you enough feedback on what you need to do so that you can finally essentially get an A on that homework. Okay. So, so I like to say that this course is an opinionated and hopefully frustrating-free crash course in full stack app development. So let me define what that means. Because again, you have to understand the field of web apps, the field of web development is vast. So opinionated in this instance means that there are many ways to do things on the web, and you can't learn them all at once. So we'll cover the ones that I think will get you to effectively learn how to make web apps most effectively by the end of this semester. And so once you understand the core concepts, and once you understand some of the technologies that implement the core concepts that go into a full stack app, then you can start to explore out on your own other technologies. And what I mean by that is I might select to teach React in this course, but there are a ton of other front-end frameworks and libraries you can use. So you could use what you've learned about what the intention of using React is when building a web application, and then later on explore, well, what if I use Angular instead? And when I mean hopefully frustrating-free or frustration-free, I'm going to try to slowly go through these essential concepts. I'm going to labor to produce step-by-step labs so that starting with a base sum of zero knowledge on any of these technologies, you walk through iteratively designing an app that is complete, and then you'll use that technology to try to turn it into homework. There'll be some obvious stuff that we might just not have time on, and for those obvious stuff that is not covered in either the labs or the lectures, then use the tutorials or the essentially the MDN or W3 schools or some of the resources that I provide on Moodle. I also provide a lot of, I think, good videos on Moodle too, so that you can really hit the ground running. Okay, so the goals for my class here. So if you never take another web programming class again, I want you to have the following skills. You'll be able to create attractive, responsive, full stack web applications that look good on either a browser and landscape, on your laptop and browser in landscape mode, or look good on your phone in portrait mode. You'll cultivate and develop a vocabulary and background knowledge to understand how to use these applications and be able to discuss how to use these technologies. So if you did go into a job interview, you would know how to talk about them and be able to show them off as portfolio work. And finally, my goal for this class is to give you a foundation so that you can take this and further pursue areas in full stack development that you're interested in. So let me talk about non-goals, things that are not intentions of this class. This is not a class that will turn you into a senior level front-end, back-end developer. And no class can do that. That just comes from experience. All I can do is give you the seeds, and the more you try to water and feed those seeds, the stronger you will be at app development. So if you kind of get discouraged at any time, just understand you've only been doing this over the course of, even at the end of the semester, a couple months. And so many people who have been doing this professionally, they've been in the business for years. Also, this is not a class that will teach you all there is to web programming because it's just too vast. There's just too much to it. So again, it all comes down to that opinionated approach. I'll teach you what I think is important. Okay, so quick disclaimer. This is a newer offering. This is only the second time I taught that class, and I'm refactoring it for this approach as opposed to last approach. In fact, the last approach, I really designed everything to be an in-person class. So now this is an online course. So what does that mean for you? Everything is subject to change, including everything I've just told you and everything I'm about to tell you. So you can't take any of my words as law. If I see that something's not working, I'll have to try to refactor it to make it better. So there will be the common mistakes that happen for a newer course offering. There might be bugs in my homework or my labs because I'm authoring these typically right before I'm giving them to you. There might be some awkward lectures, and some things might be too hard or too easy. I don't know yet, because you're gonna help me assess what are good measures. So just be patient and try to give me whatever kind of feedback you're feeling while going through the semester through Discord. Again, I'll try to make myself available through Discord essentially 24/7. I can have some crazy wonky hours sometimes. Okay, let me see. I see we have a message here. Yeah, Sublime. I like Sublime a lot as a text editor. I've been using, I think, Visual Code recently. That's been a pretty nice one as well. GitHub has one called Atom that is a pretty good code editor as well. Okay, let's see here. So let's talk very briefly about what the roadmap of technologies in terms of a visualization for a full stack application. So you want to think that there's going to be three, when you hear full stack, and you've probably seen the pancakes that I put because pancakes come in stacks. When you think of stacks, you want to think of the various dev environments or runtime environments that your one application can exist on at any given time. So full stack apps are networked apps, right? They're web-based apps. A part of the app can exist inside the browser, and that's the part that we'll call the client end. So browsers are these hugely powerful applications that were initially designed to be able to parse and render HTML documents. Now, HTML documents can either be opened using the file protocol, which means that if you double-click an HTML document on your computer, the application that launches to try to read and display it will be whatever your default browser is. But these browsers, which could also be called web clients, also have a different mechanism to get HTML documents. It can get it through the internet using a communication protocol called HTTP, which stands for Hypertext Transfer Protocol, just like HTML stands for Hypertext Markup Language. So you can imagine this was a protocol designed for delivering HTML documents from remote locations. And so there's this nebulous, like, I don't know, internet online interface where your client can send a HTTP request to some web server, which listens for that request and then responds with it for whatever the desired HTML page is. Now, HTML pages, and I'll cover this a little bit more in detail in the next couple of slides, you can think of them as the starting point for a web application. So they are set with the initial set of content that will display inside of a browser viewport or browser window, but they can tag along friends. Like an HTML can include dependencies, and those dependencies can be CSS files that might define how the web page or web application should aesthetically look. like whether elements should be centered, what color they should display at, what kind of font they should use. They can also include JavaScript scripts, which can define programmatic logic that occurs inside the web application. So by default, initially you request an HTML page, and the HTML page tags along all its other dependencies to make the front end of the application work within the browser application. So browsers parse HTML, they parse CSS, and they also have their own internal JavaScript runtime environment. On the other end of that, right, so if this is your client end that requests HTML documents and its dependencies, the thing that services that is a web server. So your web server is here. Typically, a browser or web client talks to a web server through an API, and the mechanism that, or the definition we usually use to reference that API that's visible from the client to access things from the server is what's called a REST API. We'll talk more about that when we get to web servers, but this is just a zoomed out version. The web server itself is usually a client to a database. So usually there's this client-server relationship between the web server and where all the data is maintained. The reason for that is because you might need to scale out to have multiple web servers to be able to cater to even more browsers, but you always want to have one source of truth. So this allows you to have 10 web servers that all serve at the same page, and they can all point to one database. And this way you can scale traffic up. So that's just a general notion as to why you might want to have your database separate as a separate service than your web server and your application logic, which might be a different layer than your browser logic. And again, if this doesn't make sense to you, this is just, again, the first day, and we're covering over a lot of concepts, but it will definitely make more sense as we step through this and look at each technology in isolation. I'm just trying to give you a roadmap to understand that we're going to learn how to implement at this layer, we'll learn how to implement in this layer, and then we'll learn how to implement in this layer. Oh, by the way, when I screen share, if I move my mouse around, are you seeing that?
Yeah, you see it.
Okay, perfect. Okay, perfect. Okay, so moving from this more visually image of computers and server racks and databases, what it would look like in terms of a technology perspective is what was in the syllabus. So again, we have these certain technologies that we would use on the client end, these certain technologies we would rely on at the server end, and these certain technologies that we would rely on our data base end, and the way that they communicate across each of these layers. Again, I don't want to get too much into the details because we haven't started developing anything. It's just to give you an idea of where we're going. Okay, so with that said, I anticipated that we could start talking about front-end development. That's going to be Unit 1, so I want to start with that today. I'll give you a quick crash course in a web client, which is going to be the browser. I'm going to give you a quick course on HTML, and then I'm essentially going to assign everyone to be able to start working on the first lab due by essentially the end of the week. And so I'll try to show you what that looks like in just a moment. So let's start with a browser. I'm pretty sure I discussed this before I hit the slide, so I'll try to walk through this really quickly. We have our web client, a browser here. Web pages are written in a markup language called HTML. That's what HTML stands for, hypertext markup language. The hypertext just means that it can be a document that can reference other texts, and you can navigate towards other texts. So that was one of the very powerful things about hypertext that you couldn't do with like standard text in a typical Word document, is you couldn't jump from one part to another by just clicking on it. So browsers display, so the browser's initial purpose was to display a web page by reading and interpreting them and then displaying them in the viewport. The HTML might link to other resources like images, videos, or JavaScript or CSS files. So this HTML file, in order to render properly, might depend on all these other things: images, JS, CSS. Now, like I said, there's multiple, as I said previously, there's multiple ways that we might open or access an HTML file. Initially, we'll use the file protocol, which is where you can just double click on an HTML file and it just opens directly into your browser window. But eventually, we'll want to use the HTTP protocol because there are less restrictions for that protocol when opening up HTML documents. For security purposes, the file protocol is limited in what it can do. So there will be some implementations you might want to try to accomplish, but if you open it using the typical file protocol just from local storage, you won't be able to. It'll be restricted. So I'll give you instances of that in the future when it's relevant. So the powerful thing about the HTTP protocol, though, is we cannot just open something locally by hosting a local web server or something on localhost, but we can access from any web server using a URL. So again, the idea behind a web server is just a program. It's just an application that runs on some other computer. It could be on your local computer or on some remote computer where its sole job is to deliver a web page in response to a request. And so the web page can either be one that's stored or it could be generated from the server end. So an example of trying to access a HTML page in your browser is you might type in the location of that page. It looks just like a URL. That's exactly what a URL is. When we go ahead and then hit the submit on our browser with that URL, the browser that is at that address will be requested to get the HTML page that's inside of the address bar. The server will respond to the browser saying either they have that HTML page or they don't. Let's assume that they do. So it'll say okay, and it'll go ahead and deliver that HTML page to the browser, which will then read it, parse it, and then load it into memory. And it loads into memory into what we call the document object model. So we can do all sorts of cool things like play around with it in our JavaScript runtime environment. But before it can display, the browser will then check the head element on the HTML page and decide what dependencies it has. And so all these dependencies are usually also hosted on either that web server or some other web server that's defined within inside the HTML. So if it needs any styling sheets, it'll go ahead and request for that to get delivered to our browser. If it needs images, it'll go ahead and have that requested to the browser. Once all the dependencies have been imported into our browser, then it will render the complete web page. And so that's pretty much what's happening underneath the hood whenever you load a page on the internet on your browser that's either on your laptop or on your mobile phone. Now, obviously, this was really hand-wavy. We'll go into much deeper detail as the semester goes. This is just the big picture view of what's happening. So the big takeaway about why browsers are so great. So first of all, they're able to parse and view HTML documents. They're able to parse CSS or your styling documents. They're multifaceted in the way that they can launch documents into the browser. You could either use HTTP, you could either use the file protocol, or you could use WebSockets if you need something equivalent to real-time communication. They have other protocols too that we won't look at, like FTP and whatnot. But we'll pretend that this don't exist. They have their own JavaScript runtime environment for every individual page or tab that you might open up. And then the browser itself has an incredibly in-depth API that we'll kind of look into, like the ability to do local storage, to store data on the browser end, the canvas element to be able to render graphics, the ability to store a certain amount of information like cookies, so we can start having sessions, unified sessions between our web client and our web server. And again, we'll go into more detail about this in the future, but I can't highlight enough how powerful client-side browser-based applications can be, or even full-stack applications that run within the browser. So as you might recall from your Java class, and I know everyone had to take Java, one of the big things about Java as a programming language is its portability. Java, what makes Java so popular is the fact that every Java application that's written runs on the JVM. So as long as a piece of hardware supports the JVM, your Java application will run on that platform. That's huge. That's the concept that you write once, it runs everywhere. And so that is kind of the golden standard that one seeks. Not all languages is this true. There are some languages, and one particular one that you had probably already taken, or if not will take, will be assembly. Like the entire point of assembly is that it is a machine-specific language. Assembly is the polar opposite of portability. Every application that's written at the assembly level can only run on that machine, on the machine that uses that set of instructions, that uses that type of machine code or processor. So on the flip side, these very abstracted runtime environments where it doesn't matter if it is on a Mac OS or on Android or on a Windows or some like Ubuntu or Linux distro, like as long as you have a browser, you can run your web application. So it's very similar. So web applications and browser-based interfaces are very similar to what the JVM provide in terms of portability, but it's even better. It's like the JVM on crack, because whereas the JVM, the source code runs everywhere, but it defers all of the graphic user interface, all the windowing systems to the underlying OS, so that you can have distinguishable differences in the user experience. The browser handles the user interface very similar within the browsing window. So it takes the concepts that Java made popular about trying to find a platform where you can run code everywhere, but then it extended that to also include being able to define a front-end system, a graphic user interface, a windowing system that also aesthetically is responsive and can look similar no matter what the platform is. And so that's one of the very powerful arguments as to why browser-based applications have become so prevalent in development. And there's a reason why there's such a huge market for there. The other big reason is that you don't have to download anything, right? Any assets that are required for the application to run get imported and loaded directly within the browser. And so another reason why full stack applications are really popular is security. Like the browser itself is this incredibly walled off garden, so to speak, that's virtualized and separate from the other processes that occur inside your OS. And so if you have a browser-based application, it can't escape outside the confines of the browser. So the source code can't necessarily do something nefarious unless you somehow give it permissions to do that as an end user. You don't have, an application doesn't have access to network sockets from the OS level. It's restricted to web sockets that can only be opened at the browser level. The browser does not have direct access to your local file hierarchy to load in. So you're protected there. A lot of times it's got to be imported using the HTTP protocol, and a lot of cross-scripting stuff is usually prevented by default. So browsers offer this huge, awesome capability of having distributed code base that can run everywhere and that is secure. And really, that's the big argument as to why you should want to learn how to build applications in it. That's why there's such a huge marketplace for that. Does that make sense to everybody?
Yeah, we're good.
Yeah, sounds good.
Excellent. So let me give you a quick course in HTML. I'm going to spend my last 15 minutes just talking a little bit about HTML so that you'll be primed and ready for the lab that I have posted on Moodle, and it'll be labeled Lab 1 HTML. where you'll build an interactive story, essentially. So what is HTML? So essentially, it stands for Hypertext Markup Language. It just describes the content, the structure of a web page. It's what's called a declarative language. CSS is also a declarative language. Declarative languages are just languages where you declare things. There's not any logic that has to execute. There's no state that can be mutated. When you declare something, it's been declared, and then you move on. So for that reason, they're very easy languages to learn, because once you learn how to declare the content, then you've learned the facets you need to with the language. There's very little intricacies on top of that. JavaScript is an imperative language. You know, Java is an imperative language. These are stateful languages. These are languages where you can have control flows and you can define variables that can change states and whatnot. And so those are going to be languages that will allow us to implement logics into our web pages to make them more interactive. But initially with HTML, we just declare things. So it should be relatively simple to learn. The hardest part about learning HTML is just learning what all the tags do, or what all the elements do, and what attributes you can apply to the elements. And so that's just something that comes with experience, which is what the lab and the first homework are really going to challenge you to do. So with that said, here's just a quick example of what HTML code or encoding would look like. Your elements, so HTML is defined by elements. Elements have an opening tag and a closing tag. So for instance, this P here, P stands for paragraph. So this is saying we're going to create a paragraph element. In between the two tags is going to be the contents of this element. So here would be HTML is awesome as text. So that would actually get rendered inside the viewport. And then we also have another element. So anything in between angled brackets defines an element. Most elements have an open and close tag. Some elements can have attributes that do something that give additional information to that element. But there are sometimes these rare cases where an element can just have a single tag. So for instance, the image element only needs a open tag. There is no close tag for it. You could make it an open and close tag by putting the / after this. I can't edit, but if I did, I could do that, and that would run as well. But that could be omitted, and it would still render correctly in your browser. So I you know, for clarity's sake, I'm not all about the / inside my image tags. I just do an open tag without the close tag. Okay, with that said, you can have nested sets of elements. So notice inside of our paragraph element, the word awesome is itself encapsulated by an element. EM, short for emphasis. Typically, we don't normally use emphasis or strong. We would use styling to be able to decide whether we want something to be bold or italicized. But it's good just to play around with the pure HTML before we get into the styling. So what's going to happen here is it's going to say HTML is awesome, but awesome, when it renders in our viewport, would show up italicized. Then we would also have an image. Notice that this image only has the one tag, and there's an attribute that's defined in the head tag, or the only tag we have, where the attribute name is source, and then the equal sign sets that source to some value. And the value of our attributes are defined as strings. So the same way you would declare a string in Java, a very similar way you could declare a string in JavaScript. So I want to say that as we learn JavaScript or HTML or CSS, a lot of the concepts you might have learned from Java could carry over. And so you should see that the more we start inspecting the code and looking at things. So here, I just wanted to illustrate here that we have an element that has contents. This element has nested elements and their children. And so one of them is going to change the way that one of these words renders. It'll italicize that. The other will embed an image. In order to embed an image, you need to know what the source, what the file path of that image is. So it's got a source attribute where you can set with whatever the file path and the file name is for that image. Is there any questions with that, or does that make sense for the most part?
Makes sense.
Excellent. Okay, so let's talk about the basic HTML page structure. the first line of code, and this is actually optional, but it's good practice to put in. Although I think I forgot to put it in my lab, so it just proves that it's optional. Is to define what the doc type is for this for the HTML document. So this statement here, when it first gets parsed by the browser, will let the browser know that this is an HTML5 document. So you got to understand that HTML has been around for a long time now. Since we've had web browsers, we've had HTML. HTML has gone through many different revisions. We're currently on HTML5. The default parser that your browser will use will be HTML5. But if for any reason you had a legacy page and you wanted to load it with HTML specification 3 or HTML4, this is where you would do that. So this is why it's optional. All of the code that we will be writing and authoring will be HTML5 compliant. Okay, so as I said before, everything in HTML is defined as elements, and elements are defined as an open and closed tag. So the root element of every HTML document is the HTML document. It lets the browser know my HTML code starts here and it ends here. So you could think of these tags the way you would think of curly braces in Java. This is my open bracket. This is my closed bracket. But instead of just brackets, we give context. This is where the HTML starts. This is where the HTML ends. And so HTML documents are made of two parts. They have a head part and a body part. The head part is all of the dependencies that the browser needs to be able to build the page and get it ready for rendering. The body is going to be all the content that is actually visible and displayed to the end user. So all of the text, all of the images, all of the lists, all of the tables, all of those concepts would go into the body. The head would be where you import the CSS file. It's where you would add a title. And for title, we're not talking about a title like a heading title. It's the title that appears up here in the tab, right? So it's like all the metadata associated with the HTML page. Yeah, that's right. So if we have doc type HTML without specifying like HTML3 or HTML4, default HTML is 5. That's absolutely correct. And so whenever we move to like a specification HTML6, it will then default to HTML6. But we don't have to worry about that. Okay. So, here, this is just illustrating what I just explained moments ago, that the head is for all the metadata. It's the parts that do not go into appear in the viewport, and in the body is going to be everything that renders in the viewport of the browser. And I explained all of this, so I will move on. And so here are just some basic HTML elements. You should cover all these in the lab. You have your top level headings. Your headings are going to be what are called a block level font. And I'll distinguish the difference between block level and inline level elements soon. But it's going to be a block level element where you could have a title for your where you can have a title for whatever the web page is. So you have up to 6 different sized headings. And so H1 would be the largest heading you could have. H6 would be the smallest heading you can have. So if you have like subsections and subsections, you can keep reducing down your heading level all the way to 6 degrees. The P tag is just short for paragraph. One of the big things about these tags, all the contents inside of one of these elements, is that it will ignore whatever the original formatting is. So it will get rid of your break statements. So if you had several lines of sentences that are separated by line breaks, all declared in one paragraph tag or all declared in one heading tag or whatnot, it will ignore those and just auto wrap them together. So if you want to have a line break, you actually have to define a line break similar to how you would have to define a line break in Java. In Java, it's escape code N, right, for new line. In HTML, it would be angled brackets and then BR. And again, this is a single element tag, so it just has a heading tag. You can sometimes close these off. You could have these single tagged elements have the slash to represent, that's also the closing tag, but it works fine without that. So you could just do angled brackets BR, and your browser will parse that just fine. And I think I probably use that approach in my lab. We've seen this already, kind of an image element, and an image element has an attribute. Attributes are defined inside the head tag. So this attribute is source, and it defines the location of the file name cover. And we can also have anchor tags, which can hyperlink or produce a link to somewhere else in either this HTML document or some new HTML document. So it needs an attribute. All anchor tags need an attribute called href, which is short for hyperreference. And so that lets you know, if you were to click that link, what does it link to? And then you can also have like these formatting tags that can cause things to be bolded. Strong does that, or emphasize things. That's what EM does. The old standards for that was B and I will also bold or italicize things. So really, like, the last thing that I kind of want to talk to in my HTML crash course before I feel like you're equipped to be able to do the lab would be to go ahead and know the difference between a block level element and an inline element. So a block level element is an element, an HTML element, that consumes the entire width of the viewport and creates a new line after it. So anything defined in a block level element is on its own line. And so anything else that's defined afterwards would be on a separate line. So heading elements, paragraphs, div tags, div. Div is the generic block level element we can define if you don't want to treat something as a paragraph text or as a heading text or something like that. So it's just important, when you hear a block level element, just means that it's one that is autonomous. It's an element that's rendered all on its own within the viewport, and any element that comes after it will render on a new line. An inline element is the opposite of that. It's an element that can share the same line, and it only consumes as much width as is required. So say, for instance, an image is a inline element. A hyperlink, an anchor tag is an inline element. A span tag is an inline element. And so if I had an image that was 200 pixels wide and I had 1,000 pixels of screen real estate, then that picture would only take up the 200 pixels. And then if I had text that followed, that text would render right to the right side of that image. So it's important a lot of times to know when you're creating your HTML document, whether you're using a block level or an inline element, based off of the aesthetic you want the end user to be able to see. So with that said, that should define enough HTML for a conceptual understanding of it. So I would state that I have created a lab, and I'll actually show you this lab really briefly before we run out of too much time. I know it's 3:16, but just bear with me just to show you. So this is going to be the lab. This is posted on Moodle. I just want to say, I know the labs look big. I know the labs look scary. What is this? This looks like it's like 25 pages long, but it's because everything's explicit in here, and it's just step-by-step directions. So it's big because there's a lot of spaced out formatting, and there's lots of step-by-step instructions, and they have lots of things of what to tell you to do. So the length should not scare you. You should be happy to see it's big like that, because there's a lot of information there. So really, the thing that I want everyone to do after today's lecture is, it would be great if you could start this lab before next lecture, because next lecture, what I'll likely do is conceptually talk about CSS, but then I will talk about questions about this lab that people are having issues with. I expect this lab to take about 2 to 3 hours to complete, just following the steps. And if you have problems, you can ask me right on Discord about that. But I think I have this lab due midnight or like 11:59 on Friday of this week, and you should hit all of the important elements going through this lab. In this lab, you're going to be building an interactive story game. This is like a choose your own adventure game, which will then be the first homework. It will be to take the content that you saw in this lab and actually design your very first HTML application, which will be a choose your own adventure game. And so I think I have the due date for that as Friday of next week. So please start working on that early. I will say I do give a bonus. Let me go to the very. I will give up to 20-point bonus for what I'll call a showcase bonus. So for those projects that I think are exceptionally high quality, and that I could tell that student has put a lot of time in creating a fantastic demonstration, I will build a showcase page for this class where I will host it, and then you can cite that you have a published application on your resume if you want, and actually linked to the projects there. And again, it's also up to a 20-point bonus depending on how outstanding that project is. Okay, so with that said, I think I covered everything I really needed to. We talked about the syllabus. We talked about full stack applications, how browsers work, how HTML works. I'm showing you that this is posted on Moodle now. I've gotten everything on everyone's Discord, and also the first homework is also posted as homework 1, and this document is also available on Moodle. So the other documents are tentative. This one is no longer tentative. I just finished authoring this one today. So this is the follow-up to the lab. So once you're done with the lab, you can use your lab source code as a basis, but I want everyone to create their own interactive story. And one of the nice things about this is it's one of the rare applications you could do in pure HTML without having to know CSS or JavaScript or anything else. Although I do cheat a little bit and do some script tags at the tail end of the lab. Okay. With that said, I'm out of time, so let me just open the floor to any questions before we end our first day of lecture. Does anyone have any questions? Let's see. Are we creating the HTML lab file inside? Yeah, so you can do that. So what so I have the starter file for the interactive story HTML. That's also hosted on Moodle, or you can grab that from the GitHub directory. But that's really just to have the image assets, the audio assets, and the video assets. So as you follow the lab, you'll actually have the media that you can attach to it, so it opens up as the actual content and not like a broken window box. So all the HTML you'll have to produce on your own. All the assets are given in the starter files, and that'll happen occasionally. Sometimes I might even give you the HTML, and then you might just have to do the CSS for the next lab, or I'll definitely give you like the image assets that you'll need to get these labs complete. Okay, perfect. Not particularly. Nope. Well, I hope everyone's excited about this course. I'm trying to get through the early parts as quickly as possible so that we'll have more time at the tail end of the semester to examine the deeper things that are more interesting. So like I said, I'm going to try to make sure that everyone's comfortable with the basic HTML, CSS stuff early on, because I really want to spend and maximize as much time as possible for this lecture, for this class, delving into JavaScript. And both JavaScript on the front end and JavaScript on the back end. So it'll be nice that we're doing full stack JavaScript, so we only have to learn the one language. Okay, well, if there's no other questions, please everyone join the Discord channel. Make sure that you signed my form. Just let me know that you've attended today's lecture. And if you run into any issues on the lab, please either message me in Discord, or I prefer if you talk in the general channel so that everyone can see these questions, help answer or read the questions, and have their own answers kind of fulfilled without getting like the same kind of question like multiple times, especially if it ends up being a bug. Like I said, there might be bugs in some of these labs since they're just being authored. So you might have found the bug. So please, please, please share in the Discord channel. Okay, with that said, we will pick up more with talking about some of the choices of the lab in HTML next semester. So I will highlight all parts of the lab. So if you want to pre-prepare for that, start working on the lab now. And I'll also cover the beginning parts of CSS in preparation of lab 2, which will be CSS. Excellent. Okay. Well, have a great day, everybody.
Thank you.
You're welcome. Okay, I'm going to stop the recording. Stop recording.